on creating a graph of a wave from an equation. Again, this can be a difficult task. The first thing we need to do is kind of figure out what our A, all those values are. So this would be considered our A. This would be considered our K value. So this is vertical stretches and compressions, horizontal stretch compressions. This is D, which is horizontal shifts. And the last one is a C value, which is vertical shifts. Okay, so we need to make a graph. And the very first thing to make a graph is we need to build a scale. So due to the limits of our page size, this is about as tall as we're going to build it. And we can probably put the middle line somewhere like that. Actually, we're going to go up to 14, so I can probably bring this down a little more. And I'll talk about why I can do that in a second. Okay, so in a normal, because this is essentially a sine wave, okay? In a normal sine wave, you know, we go up 1 unit, down 1 unit, up 1 unit, down 1 unit. So those are our maxes and our mins. But two things are going to affect our max and our min. First one is going to be your A value and your C value. They're both vertical movements, so they're going to affect the max and the min. And the very first thing they're going to affect is actually the equation of the axis. So the equation of the axis for a sine wave is when y is equal to 0, right? We have a horizontal line cut right through the middle. Your C value is your new equation of the axis. So our new equation of the axis is 14. So that's going to be the middle of our wave, no matter where it ends up on our page. So if we know that's the middle of the wave, we can kind of, you know, we can draw our new equation of the axis, you know, like somewhere in the middle of the page. We know that this will be the middle of our wave here, okay? And we can kind of build a scale around that. The other thing we need to know is the amplitude. And your amplitude, in this case, is your 12. So your amplitude is how much above and below 14 we're going to go up. So if we know that this value here is 14, okay, our amplitude tells us that our max value will be 12 units above that, so we're looking at 26, okay? And it's going to go 12 units below, so 2. So we know our scale has to be at least as low as the number 2 and at least as high as the number 26. I got 1, 2, 3, 4, 5 places to do this in, so let's go up by maybe 6s, let's say.
Yeah.
Yeah, so if we go 6, 12, 18, 24, and 30. Perfect. So that'll encompass everything we need to do. So that gives us a vertical idea of where things are going to be. 12, 4. Oh, the equation of the axis is right at 14. Works out very nicely. The other thing we have to consider is the period. Normally, if we're working with degrees, we're looking at like 90, 180. We need to get within 360 to show an entire period. This one, our period is changing immensely. Okay, our old period, so you can use this little formula that the new period is equal to the old period divided by k. So our new period is going to be 360, because that's the old period of a normal sine wave, divided by 30, and that's going to give us 112, 12. So the new period is 12 units. Okay, so and I think this question has to do with flight path or tides, I think. So it's going to take 12 hours, it looks like, for one of these cycles to occur. And they asked us to go from, what, midnight to midnight in our question? Yes. So we need 2 cycles. I know I didn't write that in our video or whatever, but they want 2 cycles of this. So you have to keep that in mind. We need 2 cycles. So if the period is going 2 cycles of 12, we need our x values of time to go from 0 to 24 at least. Okay? Not quite. So we'll have to go by 4s. So 0, 4, 8, 12, 16, 20, and 24. Okay? So all of these numbers will kind of detail everything we need from this graph. Okay? So now that we have a whole bunch of that information, there's a couple ways we can plot these points. You could, if you really want, plug in the x values. So 0, 4, 8, 12, 16, 20, 24 in for t. And every single time you'll get a y coordinate, and you can kind of just put dots around a page and connect the dots. That's called like a trial and error method or a table method. You could always do that. Or we can kind of talk about how things have been squeezed here. Okay. First of all, if we have our original sine, we know we've stretched this horizontally. We know we have a new max, so let's put a new max in. We said the new max would be at 26. So let's put a line in for that. The max value, we'll do it in red, is going to be at 26, which would be probably about here. Okay, and the minimum value is going to be at 2, so that's probably about there. So we know we have a new max and a new min. max is 26, and your min is 26. Okay. Did they give us a starting point for our tide in that question? Did they tell us if we were at midnight where it would be or anything like that?
No. They just said T is the time past midnight.
T is the time past midnight, so hours past midnight. Means, and this is fine, we can find a y-intercept. In other words, when it starts. Okay, so this would be considered our midnight for the question of the tide. At midnight, what's our tide? Well, midnight is going to be the time of 0. So we plug 0 into here, and we can find out what the height of our water is going to be. So D would be equal to, what do we say, 12?
Yeah.
Sine 30. T is going to be 0, minus 5, I think it was.
Mm-hmm.
Yep. Plus 14. Okay. And we can find out exactly what the y-intercept is from this value. So equals sine. This is going to be negative 5 times 30 is going to be negative 150. Looking at negative 150 plus 14. So we need sine negative 150. Let's take out a calculator. There we go. I think it can do degrees. Let me see the preferences here. Yes, okay, it should do degrees. So sine of negative 150 should give us negative 0.5. Okay, so what I just did there was I calculated this part. Okay, and I still have to multiply it by our 12. So we have 12 times negative 0.5. That's what that equated to when I put it into the calculator. Okay, negative 0.5. When I multiply 12 by that, it's going to give me negative 6 plus 14. And negative 6 and 14 is going to be 8. So it looks like we have a starting value. Is that right? Yeah, that should be right. We have a starting value of 8. So it looks like we're going to start here. So that's pretty different for our stuff. Okay, and from there we can kind of figure out, we said the period is going to be every 12. So we know 12 hours from there we're going to be at the number 8 again. Okay, we know that we're going to be crossing this coordinate, but we know those aren't maxes or mins. If you remember, this point is a max and this point's a min.
Yeah.
So we have to figure out when we're hitting our max and our min as we go through this. One of the ways to do that is you could plug 26 in for the D and then isolate for T. And we'd have to use like inverses and stuff, and you'd find out when our max is in. And you can do the same thing for your mins. Or again, like I said, you can plug values in and out. What we'll do is we'll graph this sine function with 12 being the A value, 30 being the period, and 14 being the phase shift, but we won't include a 5, a movement of 5. Okay. We'll assume that's number 0. In other words, what that means is you'd be starting right here with that one, okay, right at the equation of the axis. So this will be before we actually end up shifting everything. So we'll say we started in green. So assuming that this is that point, we know we're going to have a max value of 12, okay, and because it's positive, we're going to head up first. So because it takes 12 for the entire period to happen again, we're going to go up, cross this axis again, come down, and then come up. So halfway between these 2 points, 0 and 12, we're going to cross the equation of the axis again. So that's at the number 6. Okay.
Oh, so
and then we know we're going to go up halfway between those two, which will be 3. And we know we're going to go down halfway between these two, 6 and 12, which would be at 9. Okay. So we know that at 3, 6, 9, and 12, these are important values. Okay. Essentially, this is happening. My hand's not very good at this. Then what we can do, now that we know that, is that we can use our shift. And we can shift it over, because it's a negative 5. We go in a positive direction, 5 units. So we can move each of these 5 units to the right to find out where the new graph is going to be. So the new graph, we'll do it in blue. So 0 now starts at the number 5. Okay. 3 is now at the number 8. Yeah,
oh, okay.
And you can kind of just shift everything that way. 6 is now at 11. 9 is at 14. And 12 is at 17, is it? Yeah. Okay. And then from there, you can kind of go backwards and forwards again. And that's how they would have gone back and then come back up to here. You would have had to figure out this would have been a 2 value. And you can continue that as you kind of go along. Everything 5 units in a positive direction. we can start to figure out the missing parts here. For instance, this was 14, and our period was 12. So if we take 12 away from 14, we know we're going to have another minimum at the value of 2. So we can kind of connect the dot there, and we found out what the y-intercept by doing some calculations before. And then from there, again, you can kind of just continue. 14 plus 12 would give you 26, so we'd kind of be past that. 8 plus 12 would be 20, so we'd have a high point here. This coordinate here was 12 plus 5 is 17. That's going to be, is that right, 17? I think that's 17. 12 and 5, yeah, and then 17 and 12 is 29. It seems way past it, so let's go back to this one. This one was 11 plus 12 is 23. There you go, that's a good value to look at. So there's about 23, so we would come down and pass. Okay, so our blue one is kind of our tide coming in and out. But the question, and I know I didn't write the question in, the question is asking, it's too dangerous to land a seaplane when the tide is below 3. So 3 is roughly here. Okay. So anything above that, as we can see, is majority of the times is above. Okay, so from our graph, we know we're going to have a couple spots within that 24-hour time frame, right? Looks like there's going to be 1, 2, 3, 4 major small periods of time that it's going to be unsafe to land a seaplane because the tide would be below 3 meters or 3 feet. I can't remember what it's measured in. Now, we need to have a pretty strong grasp of trig to get the exact values. I've put it here on a graphing calculator. Oh, that's not the one. There it is. Our exact times. Okay, so remember these were our minimum values: 14, 2, 2, 2. These were our peaks at 8, 26, 20, 26, and there was our equation of the axis. I put this black line y equals 3. This is where it's intersecting. So you can see at 1.2 hours, 2.7 hours, at 13.2 hours, and at 14.7 hours, anywhere between these values and these values, it would be dangerous to land that plane. So for my graphing calculator, it's simple to see, and I put this x at 25, showing that that's kind of the end of our time frame there. That would be the next major coordinate. So from a graphing calculator, it's easy to find. Now, if you want to see how to do it, we do need to have more of like a grade 12 concept of our skills of our trig. So I'll actually show you how it is. We kind of have to already know what the unit circle is. So in this one, what we're asking for is we need values that are less than 3. So we take our original equation, 12 sine 30 t minus 5 plus 14, I believe it was. And we need values that would be less than 3. We also have to know our cast system decently well. Okay. So in order to isolate for t, because we're looking for the times, we're going to bring over our 14, positive 14 first, and then divide by 12. So when we do that to the other side, we're going to get 3 subtract 14 divided by 12. Okay, will equal sine. And there's a reason I kind of stopped at this specific point, because this is going to give us, that's not an S, that's a 5, some very important information. This will give us negative 11 over 12. And then to bring sine over, we look for the sine inverse of this. Now, it's equal to 30 times t minus 5. This part right here gives us quite a bit of information about our unit circle. Okay, because we know that sine is, or sine theta, whatever it is equal to the opposite over the hypotenuse. When looking for theta, the angle, we look for sine inverse of the opposite over the hypotenuse. And when we're in our unit circle, that's actually usually y over r. So that's the y value over the r. We can calculate what that's going to be. We'll use a calculator here, and we're in degrees. So second function sine of negative 11 over 12 gives us roughly negative 66. So first of all, where is sine negative? Well, we know that sine is positive in the all section and the sine section. So it's negative. Let's kind of use, I guess, some blue value in the tan and cosine section. So, and also you can kind of think of, if you're at this point, we're going back 66 degrees. So we're going negative 66 degrees back this way. That's one of our values. This also kind of tells us about our y value. Our y value is negative 11. That makes sense because in this quadrant, our y's are negative. Okay, and our radius is 12 of our circle. Okay, but not only is it negative in this quadrant, we're also negative in this quadrant here. We're at negative 60. Got to make that a 6 degrees. Okay, and again that makes sense because this is negative 11. Our radius is 12. So we're kind of looking for two values here. Okay, and this is going to be important for what we're doing. This is where we're going to get kind of two answers, and we've already got one of them. We know one of them is approximately 66, or approximately negative 66.44. So we'll say negative 66.44, okay? Now, on top of that, in order to find this one here, think of this like an obtuse angle, and we're going to take 180 degrees and subtract it from our 66.44 to find out really what this angle is, because that's the other major angle that we need. So we're going to take, and now that I know this one says negative, but we're going to take 180, and we're going to subtract this value here, and I'm just going to make it like that. So this is going to tell us what the other angle is we'd be working with. It's 113.55, so it's equal to 113.55 approximately. And when plugging this in, let's kind of jump up just a little. I've done it up here before. No, I didn't. Let's go back. We're going in a clockwise fashion. This is going to be a negative 113. So we're going to have negative 113.55. So we're going to keep those two values in mind. So now as we go to solve, they're still both equal to this. So let's kind of move this one over just a bit. Is equal to 30 times t minus 5. And this is equal to 30 times t minus 5. Okay, so we're going to find some values. We're going to get negative 113.55 divided by the value of 30, and then plus 5 will equal our t value. And on this side, we'll get negative 66.44 divided by 30 plus 5 will equal our t value. So we're going to get two values here. And actually, because this is a wave, we're going to get many, many, many values depending on what the period is. But these will give us our two major ones that we can kind of work off of. So when we go to solve these, we'll take our negative of this divided by 30. So I'm using very accurate ones with these values here, is equal to, and then I'm going to take that number and add 5 to it. And we get approximately 1.21. Okay, so t is equal to 1.21. That's one of the values. And t is equal to, on the other one, we're going to take our negative 66. That one was important to us. Okay, and we're going to divide it by 30. And then we're going to take that value and again add 5. And here we're going to get 2.78. So our times are 2.78. Okay. And 1.21. And if we kind of go over and take a look, 1.21 and 2.78 are our two values. And then from there, because we know we have a period of 12, we can constantly add 12 to these values to find out what the next ones will be. So 13.21 will be another one. And 14.78 will be another one. So we'll highlight those. And if we go ahead and look, 13.21 and 14.78, those work great. And if that's within our 24-hour time frame, but if we want to keep going, we continue that period and we constantly find new values when we're hitting those numbers. Okay. So again, you have to have a decently strong grasp of trig in order to find out those other ones. Otherwise, we can kind of use a graphic calculator to figure out what it is that we are doing.